Hello friends, today I will discuss the comparison of DC motor, 3-phase induction motor and 3-phase transformer. So here are the three columns: DC motor, 3-phase induction motor, 3-phase transformer. For a DC motor, the supply required is DC supply. For a 3-phase induction motor, the input is 3-phase AC supply. For 3-phase transformer, it is a 3-phase AC supply. For a DC motor, armature is present and it is connected to the supply and it is equivalent to the rotor in the other machines. So in case of 3-phase induction motor, stator is connected to the AC supply. In case of 3-phase transformer, primary winding is connected to 3-phase AC supply, and in DC motor, brushes are connected to the armature, whereas in case of 3-phase induction motor, brushes are not used. Similarly, in 3-phase transformer, there are no brushes. In a DC motor, the back EMF is equal to 5Zn by 60 into P by A. Here 5 means the flux and Z is the number of conductors and N is the speed of the motor and P is the number of poles and A is the number of parallel paths. Whereas in case of 3-phase induction motor, the induced EMF RMS value is equal to 4.44 phi F into N into kW. Here phi means it is the maximum flux linking with the motor, and F is the input supply frequency and N is the speed of the motor and kW is the winding factor of the motor. In case of 3-phase induction motor, the induced EMF equation is 4.44 phi into F into N. Here phi means it is the maximum flux linking in the 3-phase induction motor per phase, and F is the supply frequency and N is the number of turns. In case of DC motor, armature is connected to the load, whereas in 3-phase induction motor, load is connected to the rotor shaft. In case of 3-phase induction motor, load is connected to the secondary. In case of DC motor, speed means it is armature speed that is normally represented with N and measured in RPM. In case of 3-phase induction motor, there is a synchronous speed that is called Ns, that is nothing but the stator magnetic field which is rotating at a synchronous speed, and the rotor speed means it is represented by N. So these two terms are present in a 3-phase induction motor. And this rotor speed can be measured with the help of tachometer, whereas synchronous speed can be calculated using the formula 120F by P. And in 3-phase induction motor, the speed is 0 because it is a static device. In case of DC motor, speed can be controlled by various methods, whereas in case of 3-phase induction motor, here also speed can be controlled by various methods. And in case of 3-phase transformer, it is a static device, so there is no question of speed and there is no question of speed control. It is always at 0 speed. It is a static device. Similarly, when it comes to the efficiency of the DC motor, so it is present and its efficiency is not very high. And in case of 3-phase induction motor, efficiency is high. It is between 75% to 85%. In case of 3-phase transformer, there is output and there is input. The losses are very less. So there are no rotational losses or windage losses or friction losses in case of three-phase transformer. So its efficiency is highest in the electrical machines, that ranges from 97% to 99%. Next, coming to the rotational losses, in case of DC motor, so there are rotational losses, there is friction and windage losses. Similarly, in three-phase induction motor also, there are rotational losses which are nothing but friction and windage losses. Whereas in case of three-phase transformer, there are no rotational parts, so there is no question of rotational loss. Rotational losses are zero. Here in a transformer, so primary winding means whatever winding is connected to the supply is called the primary winding. That may be HT winding, that is high voltage rating winding, or that may be a low voltage rating winding. Similarly, secondary winding means the winding which is connected to the load or left open is called secondary winding, and this secondary winding may be a high voltage winding or low voltage winding. Similarly, in case of DC motors, DC supply has zero frequency, so there are no eddy current loss or the hysteresis losses. So there is no hysteresis loss, there is no eddy current loss in case of DC motor. Whereas in case of three-phase induction motor, so core losses are present, that is eddy current loss also there, core loss is also there, especially in this stator of the three-phase induction motor. Whereas in case of rotor of the three-phase induction motor, core loss is almost zero, but copper loss is present. Whereas in three-phase transformer, core loss is present, that is eddy current loss and hysteresis loss. In addition to this, copper loss is also present in the circuit, in the transformer. And armature DC motor speed control is possible by various methods. That may be a field control method or that may be a voltage controlled method. Similarly, three-phase induction motor speed control is also possible by varying the frequency, input frequency or supply frequency to the stator, or by changing the number of poles, or by changing the voltage, input voltage, or by changing the rotor resistance in case of slip ring induction motor. Whereas in case of three-phase transformer, there is no such necessity for speed control, because the speed of the transformer is zero because it is a static device.